I've been on 35 years of doing custom equipment design. Mostly started out in pressure vessels, then went into containment systems for both nuclear, pharmaceutical, and petrochemical industries. Like I said, 3 years ago, in February as a matter of fact, it'll be 3 years, my partner and I founded Pressure Safety Inspectors. Pressure Safety Inspectors is based in Colorado. We're down in Castle Rock. We basically have two segments. We cater to both the equipment manufacturers, people who manufacture extraction equipment, as well as facility owners, the people who actually are making the extractions. So we focus on extraction only. We don't deal with grows. It's not our, we don't do that kind of thing. We don't do the dispensaries. It's strictly extraction services. We started in Colorado and then added Washington and now Nevada and Oregon as well. So we're helping keep the facilities safe in a couple of different states. After the last election, we're all quickly applying for comity in a couple other states as well. Another thing we do is equipment field verifications. So we'll talk about that in depth. So this is going to count. If any of you guys care and you need continuing education or professional development hours for your majors, sign up, give me an email, I'll send you the cert. So you'll get something in the mail. So if you're interested, if you're not, I don't need it. It's only if you need the certificate. Boom, boom. Okay, what are we going to do today? We're going to talk about extraction equipment only. We're going to talk about UL listings or NERDL listings, peer reviews, and field verifications. That's our main objectives. Why? For extraction equipment is a solvent-based process, which has hazards associated with it. The most common solvents we're using right now are butane, propane, carbon dioxide, ethanol, grain alcohol, and we also have to deal with purge gases. A lot of people are using nitrogens, argons to drive product through the systems. It's an industrial process, so this is not people working out of their kitchen or a hotel room. We only deal with licensed facilities. So they're industrial facilities. This is not home-based extraction, okay? All of them have one thing or three things in common. You're going to have a product container where you take your marijuana. You typically will grind it to a fine powder to increase the surface area. You'll introduce the solvent into the column. You'll let it soak. The solvent takes out the good stuff. You'll drop the slurry into the collection bin where now you have your good stuff and your solvent. Now you got to reclaim the solvent and reuse it. That makes this a closed loop system as opposed to other people. So once again with the pictures, you got your LPG tank or CO2 tank. Let's just pretend it's the LPG for now. A column dropping down into a collection vessel, then pumping off, expanding the gas, recovering it back into the cylinder. And what you're left with in the can is your golden goodness, the product they're looking for. Okay? So we just described this process, and I just want to make a point, since we're all here for national fire protection, that this is not a refrigeration cycle. Refrigeration cycles can be run using butane and propane. It's not very common in the United States, but it is common in other countries because when you flash your liquids to a gas, that would produce a cooling effect, remember your Joule-Thomson effect, and that will give you a really nice refrigerator. But these systems are not a closed system like a refrigerator system is. These are opened every single cycle. They have elastomer joints, not welded joints, etc. So although there is some argument to say this could be a refrigeration cycle, that's a coincidence in our opinion. It is not a refrigeration cycle. This is an extraction cycle. And I bring that up because that's a big push in Washington and Oregon right now, is how these systems classified refrigeration. We fight that. We don't think that's true. One other thing that's a big deal. In this industry, the solvent, when it's an LPG, is not scented. So if you're running a refrigeration cycle, you'd have your mercaptan in it or whatever you're using to scent it so that a human could easily detect a leak in the system. We don't have that luxury here. You will never smell the leaks. It is unscented, food grade, propane and butane. So if you have a leak, the first time you're going to see it is when it bursts without the proper thing. Boom, boom, boom. So, our challenge, and your guys' challenge as well, is to help these people who have been doing this for years. They will tell you this every time you ask them, whether you want to know it or not. I've been doing this since before you were born. And they're probably telling the truth. This has been going on a long time, but it's always been under the radar. So these guys are very familiar with their processes, but they're not the world's experts on following the rules or regulations. They do, in fact, go the exact opposite way sometimes. That's not to say that not everyone's doing this, but it is a big challenge to write regulations and to write reports telling them what to do correctly in a language that they can understand and follow. They're not used to having written procedures. So when they're running their extraction salt, they like to tweak things. They consider themselves artists. I am making this product that will be better than the guy right next to me doing the same darn thing. So what sets them apart is that black magic. They hate to document that. So you got to help them write procedures that allow them to operate safely, but still give them a little bit of freedom to make some inconsequential changes to the process. And then training. They're not used to dealing, generally speaking, on an industrial scale. It used to be one or two guys operating. Now they're running 24/7 with multiple users. How do you get consistency? How do you make sure everyone's being safe? So training is another big deal that wasn't part of the picture 4 years ago. The actual extraction using LPG started with pipes. So the classic open blast, you guys have heard that expression? You fill, that's the plant material in a column. You take your butane refill, plug it into one end, blast it through. Oil and butane fall onto the floor at your feet. That's great if you're outside in a field and there's no ignition sources anywhere near you. If you, say, rent a hotel in Boulder and do this in a hotel room, the result's going to be what you'd expect. The butane will hit the ground, it's heavier than air, it's going to flow till it finds a nice ignition source, and poof. But that's what it starts out. That's the simplest one you can make. You can do these at Home Depot all day long. They started getting a little fancier. Hey, let's make it with steel. We'll collect our stuff with a funnel. There's our open blast can. This is a typical, what some of the product may look like. But it was still glass tubes in someone's kitchen or laundry room. Now we're starting to see stuff that looks a little bit more familiar. They're starting to use sanitary fittings, stainless steel. They're starting to make this a permanently mounted thing. It's not something you carry around, but it's still straight through. Introducing, this is the column, a collection pot, and now you have a chance of recycling it using thermal cycle. Nice thing about, remember, the LPG, because it's sort of a refrigerant cycle, you don't need a compressor to reclaim your gas. You can just run hot and cold water to get the stuff to flow the direction you want. We call that a passive operation versus a pumped operation. Getting closer to what you can buy these on the internet today. These are passive systems, columns, tanks, and you look at the quality of the stuff, you get what you get when you buy it on the internet. And this is actually really close to what you're seeing a lot of places. Now they've introduced a recovery pump. They're providing some sort of ventilation. They're using DOT supply tanks, tall, still wouldn't pass our review, but they're getting close. So let's talk about our review and approvals. Colorado rules state in, Rule 605, if you have an extraction system, they have a 4-tiered process of getting it approved. 1, it's UL listed. I think they use those words, but they really mean Nationally Recognized Testing Laboratory, or NRDL. So if you have an approval from a NRDL, they stop asking questions. 2, you don't have a NRDL approval, but your in-house engineer was a professional engineer, which means a Colorado professional engineer, then they stop asking questions. 3, if you don't have any of those, you can hire someone like pressure safety inspectors to do a third-party review. It's only 3. Boom, boom, boom. So NRDL listings. The problem being, there is no standard, there's no UL standard, there's no ETL standard for extraction equipment. So if you don't know what a real NRDL review looks like, you could fall into this false sense of security. It says, hey, my machine has been NRDL reviewed. Yay. But remember those passive systems? There's nothing on them. There are 2 tanks, no instrumentation, no nothing. NRDL looks at that and says, I'll take your check, thank you very much. And they haven't approved anything. So, case point. And we're here familiar with Extraction Tech. They're a local Colorado firm. They spent the money. They went to ETL to get a third-party review of their system. And they got it. So we looked at the report a little bit more carefully. They performed a stability test, current leakage, starting currents, inputs, dielectric. These are all electrical. They didn't look anything at the pressure-containing parts whatsoever, and it gets worse. They kind of recognized that, and they withdrew their listing in 2013. But this was a typical Extraction Tech machine back in 2012. Their only electrical part they looked at was the vacuum pump. The vacuum pump's part of this process is to pull the air out of the system before you do anything else. Then you disconnect it and walk away. So that's all NRDL got them was, hey, your UL listed vacuum pump is now ETL listed too. Kind of a complete waste of their money. And then you see the little bubble pointing to everything else, they just listed as an accessory. Various models, stainless steel. That's the extent of what they looked at it. And I don't mean to be slamming ETL. The issue is, like I said, there are no standards to go look against this, or compare your machine against. So just that the code as written by MED, Rule 605, if you're UL, then quit looking, I maintain, professionally, is misguided. Because you can go get it, and it doesn't mean squat. Where were we? So, in summary, the cons, why do I hate them? There's no procedures, they don't look at the vessels whatsoever, they don't do a hazard analysis to make sure you got things in the right places, there's no chemical compatibility, and they don't require any field verification whatsoever. On the pro side, if you do have an electrical system with a cabinet, all right, I can bid into that. You should have a UL cabinet, that's fine. But remember when you're looking at that, that's all they looked at was that box. And everything else, all the hazardous stuff, they ignored. Boom. So what's an alternative? Peer reviewed. We do these. We do a code-based review. So we start with, which one goes first? It's the building code, which invokes the fire code, which invokes NFPA, whichever one's appropriate for the gas you're handling. So we do a code-based review of the entire system. We do look at the vessels. In addition, we look at the relief system. The problem with LPG gases, or actually liquids, is when they're confined and there's no head space, small changes in temperature can produce large changes in volume, which can drive your pressure up skyrocketing very quickly. you got to make sure you don't have that case. We look at chemical compatibility. We do perform a hazard analysis. We actually read their operation and maintenance manuals. Do they adequately address all the hazards of their system? Do they tell people how to use it? And we all know that you can write a really, what's the right word? You can have one manual that's really well written and well done, and you can have one that meets the bare minimums. There's that happy medium between the two. But you can't be telling them in your manual to do stuff that is unsafe, and the manual cannot be directing them to use it in a way that's not been approved. The other thing a peer review gives you is the ability to do a field verification later. So why are they a good idea? Because there's no specific code as of today for marijuana extraction equipment, it allows professional engineers to pick and choose from the relevant codes and document it in black and white why they think this is appropriate for this piece of equipment. So it gives you a little bit of a, someone has to sign on the dotted line saying, yes, this is why this is relevant. You're not relying on the equipment manufacturer. You're making sure everything's closed loop. Reminder that open blasting, which we described, is not legal in Colorado anyway. Also gives there's very few people out there making this equipment that actually have documented third-party quality assurance systems. By that I mean ASME or ISO or any other quality program. A lot of these guys struggle with configuration management. So having a peer review puts a line in the sand that says, here's what we looked at, the drawings are there, everything that was there to document the system is there. So you can tell what one of our reviews says, it's revision 6, you got a really good idea of what you should be finding when you go in the field. And once again, they're not always qualified. And I can prove that. You go to YouTube and you just Google how to build a hash oil extractor, and how many hits did we get? About 4,500 results. So you can do this at home, boys and girls, and they are telling you to, and if you read some of these, or watch these rather, they're not really going to be highlighting the hazards. They're all into, here's how you make money quickly and, behind your parents' back in the garage. But anyway, they're out there. All right, so let's talk down to some real specifics. This is a butane hash oil extractor. I believe some of you may have seen this before. So let's take a look at it and say, what's right? Well, one thing that's right, it's got a pretty good stand, and it's easy to see what's going on because it has a glass extractor and really simple flows. I like that. But what's missing? Well, first off, it's a glass material column. Glass is acceptable use for butane and propanes. In a laboratory, this is not a laboratory piece of equipment. They run this 24/7, making as many runs as they can. They do not clean the glass. They do not look at it as a breakable element. But we all know in real life, they will break, especially over time. And glass has that unfortunate characteristic of when it fails, it's going to fail catastrophically. So even though you're only running 30 to 40 psi, if you have a glass column, where is that? Where's back? If you had a glass column that big that blows up at 30 psi in your face, it's going to be a bad day at the old extraction house. The other thing, there was absolutely no pressure reliefs on there. The gauge is only read to 60, but the gas can go above that in an upset condition. Those vessels at the bottom were 10-inch diameter with they were kitchen appliance closures. So they're not ASME, they're not DOT. They have to be in the state of Colorado. And the recovery pump they're using, that was an Apion. Remember that name, Apion, A-P-P-I-O-N. Recovery pump. Where do you buy those? You buy those at your HVAC supply stores. Why? They're made to recover refrigerant. They're not made to recover LPG refrigerants, only the old Freon and Freon replacements. In fact, Apion was having a wonderful year. They were selling the heck out of those things. And they didn't understand why. So they finally figured out they're being sold for marijuana extraction. And they said, well, that's cool. We're helping out with the cause. They're okay with that. But then they found out they're running them with butane and propane through them. They actually had to put out a letter saying, please don't do that with our machines. These are not rated for that whatsoever, but people are still selling equipment with Apions on them. So when you hear someone say, I have a recovery pump, you go, yep, that's nice. Tell me more. And you got to dig into it a lot more to find out, is that an appropriate recovery pump for the fluid they're using? Let's take a look at another one. This looks a lot like one of those early slides. This is a stainless steel, yay. Probably rated for the pressure down in here. But once again, that's more than 8-inch, or 6-inch rather. So that has to be an ASME vessel. There's no ifs, ands, or buts. There's a sight glass here. Well, that's interesting. I'd like to be able to see my fluid go through. I could tell when I got the flows going I want. I could tell when it's full. That's good. Unfortunately, that is a brewing supply house sight gauge, rated for atmospheric pressure only, and being used on, once again, a 30 to 40 psi system. And that's right about face level if you're standing next to it. So once again, you got your nice little glass enclosure rated for standard conditions being used inappropriately. No support frame. The other beauty of this one, they sold this as, you can run this for months because we have a 200-pound supply tank. So, yeah, that was a feature. We actually believe you should use the minimum amount of solvent in the room as possible. They were pushing the other way because, come on, changing that tank every couple of weeks, that's got to be a hassle. We'll give you a 200-pounder. They had a Haskell on there that got you up to 1450 if you wanted to. And remember, that sight glass is rated for, atmosphere. And there was no relief valves. Boom, boom, boom. So we don't like that one. But it was a great bomb. So you got to give them credit. You know, if you're going the right way, they also are no longer in business, which is, I think, a good thing. So what actually happens in a peer review? Well, it's a third-party review of the system. We don't design the system. So they basically bring us their bag of stuff, dump it on the desk, and say, tell us if it's good. So we go through the original configuration. We don't design it. So you usually fail the first time. But that's okay. When you fail it, you're going to get a nice little punch list. Here's what you need to do to fix it. And then they got to resolve the fixes. Then they don't have to take our advice. I mean, there's more than one way to skin a cat usually. We can point out, this is wrong and here's why. You figure out how to fix it. At the end of the day, they come back and we issue a report saying everything's okay. Why is this a hassle? Why am I even mentioning this? Because remember this? They brought us a box of stuff at the beginning and dumped it on the desk. So what becomes important is the date of the equipment you find in the field. So if manufacturer X brought us something this summer and said review it, and we looked at it and said, oh my God, that's a bomb. No. And then this fall they made changes. Okay, now you're cool. Stuff they sold in last year is still a bomb. And a lot of these guys, remember that configuration control issue? They don't have the world's greatest configuration control. So you got to look at serial numbers, you got to look at dates manufactured, compare that to the peer review before you can have a reasonable confidence that the machine is actually safe like the peer review says it is. Make sense? A lot of the guys in the field who make these equipment don't get that. But the only way you can really be sure is a field verification. So a field verification is some lucky guy gets to go out into the shop, take a look at the machine, take a look at the peer review, compare them side by side, and make sure they actually match. So that if you say I have a approved machine, is the one in your office really an approved machine? And this is similar to some of the Nerdle reviews, but it isn't that hard. We go through the P&ID, the piping, to make sure that all the components are in place, that they said they were going to put in place, and that they're in the right order. It makes a really big difference which way you put a check valve, for example, or which way you put a bypass. We verify all the vendor components. We look at the fab components. We take dimensions to make sure it's actually what they said it was going to be. We look at the warning labels that are actually in the field, compare that to what they said they were going to put on the machine. We look for that model and serial number. If you don't have a model and serial number, how the heck do you even know what you're looking at? So we make sure it's actually there. Then we document everything in a full report. Additional benefits of being out there in the field with them. While you're doing this, I think every time I've ever done it, they're right there with me. So as you're walking through the system, it gives us an opportunity to explain to them why these relief valves are where they're at, why the system's configured how it is, to make sure they understand exactly how to go through it. We talk about things like torque. We'll get to that in a second too. We talk about standard operating procedures. We talk about their alarms. That's not usually part of the equipment. The hydrocarbon alarms are going to be, separate. That's building. But we make sure they understand, hey, if you can't see it and you can't hear it, it's not really there. You followed the letter of the law. I put an alarm there. But if you can't see it or hear it, what good did it do you? We talk about the exhaust systems and relief venting, especially for CO2, and other technical discussion. So it's a good opportunity to provide training to these guys on their own equipment. Colorado was the first state to require the peer review, and then the jurisdictions actually here. You guys were one of the first to start requiring field reviews. Well, that's now taken off. Seattle's doing it, Nevada. So I think it's becoming the norm. We'll talk about why. Remember that older models, just because a PX1 doesn't mean it's a version 2016 PX1. So you got a good chance to find these. And there's the other thing, going back to their artists. They love to mess with the machine. So you may be there in the spring doing a review, you get called back later on, you look at it and go, what did you guys do to your machine? Well, we didn't like the way it was working, so we modified it. Okay, well that kind of negates everything we said earlier, that you had an A1 machine that's been approved, now you have a hybrid. And it may or may not work, but you got to have someone look at it. You just can't go mess with this stuff. Try to tell that to some people. They're also, right now, the market's mature enough you could buy, you go on Craigslist, you can buy machines. That's how a lot of guys get started. They found something on the internet. A lot of problems with those, not the least of which, you don't know what's genuine and what's not. So people are doing it, we need to be aware of it, but if someone doesn't go and actually look at it and compare it to what it's supposed to be, they're really kind of gambling there. Hoses per code, that's a common one. People change out the hoses all the time. So stuff we found in the field while doing our inspections. This is a CO2 system, so there's no flame issues, but it is operating at about 3,000 to 4,000 psi. And all these relief valves are tied into cheap plastic tubing. So when you pop off a relief valve with CO2 at 4,000 psi, that tubing is now going to be launched across the room because it's not going to vent like you think it's going to vent. When you have an exhaust system for a high pressure system, that exhaust system actually has to be engineered. You got to make sure you have the right diameter changes, that you're always expanding as you go towards the exhaust. You got to make sure it's the right material. It can't be cheap plastic. It can be plastic, but the good stuff. And you got to make sure that it is actually routed in such a way that you're not going to choke the flow later on. So that's a classic. This one was non-compliant components. This is one that they brought us their box of stuff. We said, this filter right here, the manufacturer tells you never use that for LPG. It's not rated for that service. But there it is in the field. So someone went and put it back on the machine because they were having trouble with their recovery pump. So they put stuff on that was not approved. Yellow jackets, non-compliant pumps. Once again, these are pumps that are not rated to be in a Class 1 Div 1 environment, and they're not rated to handle LPG gases. But they are a recovery pump. So people think, why should I spend this much money when I can go get this one for half the price? Typical, this should not be, this is commercial equipment. You're not really allowed to use extension cords in a permanent fashion, as we all know. But these guys did it. Placement of equipment. So this was a really common setup we found a lot. Down here on the bottom is the water system. So these vessels are jacketed. So you have cold water, hot water flowing through them. And you have a system that'll provide the hot water, cold water. That's a non-rated electrically system. So it's not meant to be in a Class 1, Div 1 or 2 environment. And it's right there in the extraction room. That's bad. But what makes it worse, what's the most common part that's going to leak on a system? Quick disconnects. So you got your recovery pump on top, where you have your quick disconnects being made and broken on a regular basis, like every cycle. If you had a leak, LPG, heavier than air, sinks down, in this case, directly onto your non-rated electrical equipment, including heaters. So you probably couldn't do a worse job of setting this up if you tried than to put this the way they had it. And this is the kind of stuff we talk to them in the field. The instruction manual may say that, but it may not explain to them, here's why you're trying to kill yourself. Don't do that, please. This is one of my favorites. Bypassing a safety feature. Let this sink in. This is a pressure vessel. This is a relief valve. This is the discharge of the relief valve. This is what the client was using to fill his vessel. So he was using a relief valve. He saw the word valve, said, well, that must be what I want to do, and tried to push fluid backwards through it, which is impossible. I said to myself, this is impossible. It can't be working. But there it is, working. How did he do this? He's genius. This is a cross-section of that valve. If you unscrew this bonnet far enough so it's just hanging on by one thread, then the relief valve piston comes up far enough to allow you to flow backwards through it. So this is one of these places where I said, okay, we're leaving now. We'll come back when you have everything depressurized, because you're going to kill yourself, dude. But that's what, they saw the word valve. It's a valve. I'm using it as a fill valve. Which one's this? Bypassing. Oh, this is the same client, but he did it not only once, but twice. So he really liked that fill valve. Sub-zero temperatures. Stainless steel, cryogenic, who cares? There's no low temperature for stainless steel. You can go as low as you want. But all these systems have elastomers, O-rings, Viton, something providing the seal. Those you do worry about. So most of the equipment is minus 20 to minus 40, and that's good for most Vitons, Teflons. But some people you'll find out in the field now are using dry ice solutions. So they're putting dry ice and alcohol to try to get even colder, which gives you a better product. So it's driven by the process, but your seals don't like that. They're going to go hard long before you get down to minus 100. And you're going to leak. And you're never going to know it, because you're not going to smell it. You're not going to see it. Your seals have just turned into solid material, and you're going to start leaking. So if you don't have a gas detector and ventilation, really nasty things are going to happen. So you can do it safely, but you got to have the right materials in place. Improper assembly. So I walked into this is a paint booth. Yay, they got high airflow, did it right. This is a common piece of equipment. This one's designed out of Colorado Springs, if I'm not mistaken, Emotex. And what caught my eye is there's a valve and a spool piece with a relief valve here. And really, shouldn't that be part of the system? Well, they didn't like the fact that there was two valves they had to close every time, So they just got rid of them, took them out of the system, and by doing so, threw away their relief valve too. So this is another modification in the field. They thought they were doing, look at all this I saved. That's how it's supposed to look. Valve, spool piece, valve. Operating procedures. Colorado requires you to have written procedures for extraction facilities. And once again, there's the bare minimum. There's some that are absolutely outstanding. And most of them are somewhere in the middle. But what I find is even the best written procedures, if they're not actually using them, are just a waste of paper. So it's always interesting, if you have an opportunity, ask the people running the machine how they're following the procedures. Just to find out. Most of them, the good ones, can tell you, yep, we follow this procedure for this run, and they know what they're doing, they've been trained. Some haven't. Let's see, this is an example of someone who wasn't trained. Well, let's see here. This is an extraction facility. She's standing in front of an extractor. Now, what's interesting, the door was left open, and the airflow isn't supposed to be doing it.
Did it just start?
So the good news is, nothing ignited. This is at only 30 psi, relatively low pressure butane system. They had a brand new employee. The training consisted of, make sure you have that cover on tight. She took that to heart. So it's just as dangerous to over-tighten something sometimes as it is to under-tighten something. She stripped the hell out of those nuts. She didn't have a torque nut or a torque wrench. She didn't really have any training other than make sure it's tight. And if you saw, she just barely escaped, quite frankly. Yeah. Because her head is right over where the reactor lid went off. And then the vapor cloud, which isn't, it's supposed to have a ventilation system in place. It's supposed to be pulling it away from her. She's running, it's following her. That's not cool. The door to the room stayed open, so it went out into the hall, and so did the fumes. So there's a lot going wrong in this particular picture. Boom. What else? The original clamps and nuts on these sanitary fittings are disposable. You shouldn't be using the same pair for years and years and years. Like I said, 30 psi, 12-inch lid, that could have hurt. Could have hurt a lot. No one had really reviewed the SOPs. When they did, they found out there was no torque mentioning. No one had ever field verified it. And she just wasn't trained, bottom line. So we make sure that all closures have some sort of training. Now, I'm a big advocate. I don't think you need to have a torque wrench every single time you close a vessel. I think you need to have a torque wrench when you're being trained how to close a vessel, for sure. Because you're going to eventually develop a feel for what 30 foot or 20 foot-pounds feels like. But no one walking off the street is going to know what that means. You need to have the right equipment around to at least train your people. Boom. And those are the nuts. So, and they're not brass, they're bronze. Big difference. And that's what the connections look like. So there's the gasket, the clamp, two pieces held together. Pretty straightforward. Let's see. Yeah.
Or River brand. The brand different. And then, here in New Mexico, you think we would pronounce Nazareth correctly, but we don't. And it was just sort of a
So this one wasn't as lucky. You might recognize that vessel. That looks a lot like one of the ones we saw earlier on. You see when it ignites, the whole floor had been flooded with gas. There was no ventilation happening. He had the equipment standing directly in front of the only door out of that room. What else went wrong? This guy got out fairly quickly, if I remember right. Boom. Yeah, so he was already on his way out. He couldn't get out. Yeah, he's also on fire. That's not pleasant. So, with a heat gun. Yeah, so that's what's going on. So he had, all right, here's another thing. This is important. I forgot to say this earlier. Real important. We call these closed loop systems. Get that out of your head. Every single cycle, you open the machine. Every single cycle, you intentionally release solvent into the room. There is no other way to do it. Closed loop means we're recovering 95% of it, but you are not recovering 100% of it ever, ever, ever. Every operation, on purpose, you are introducing solvent into the room. And that's what makes it Class 1 Div 1. It's not an accident condition that stuff got out. It is deliberate. And when it also includes the off-gassing the material. So what he's done is he's already put his material onto a plate. He lets it come out nice and smooth. You want it to look nice. And now you want to evaporate off the last of that gas. So this is what they're doing. He's just trying to use a little heat to get it to go faster. Big mistake. But everybody else does the same thing. In those rooms, you need to have a space to off-gas your product as well as the spent material. Because that packed column full of powder still has solvent in it. Even when you take it out, it's going to take a little while to breathe, to evaporate. So even though we call these closed loop systems, don't be fooled into thinking that's what they really are. They're closed more than others, but they're opened every single cycle, every single time, on purpose. Anyway, so that's what he's doing. He's got his little tray. He's applying. The initial ignition goes off. And then instantly, it's all the way across the floor. So he had no ventilation in here either. The whole room had been flooded. The guy's probably has it in his clothes as well. Do you have to wear Nomex? Probably not, but I personally would never wear anything nylon in any of these facilities. And that machine did look an awful lot like this one, the company that's no longer in business. So you also saw the advantage of having a stand. Remember when this thing falls over? So when it fell over, everything else goes out. Whatever hadn't already leaked is now going to start leaking out. So after all these scare things, can you run these things safely? Absolutely yes. You got to have the right equipment, procedures, training, etc. But yes, I don't want to say this is impossible, we should shut it down. People have been doing this for a long time. There are safe ways to do this, but we got to recognize what the hazards are and how to address them. And trying to put solutions to it like, hey, we'll make everything UL listed and that'll solve all our problems. That isn't going to work. That's not how this is going to work in this industry. We're a big proponent of peer reviews of the equipment. If you have your own engineers on staff, make them put their PE stamps on it. That's fine. If not, third-party reviews are the way to go. The procedures have to be reviewed by both an engineer and an industrial hygienist, Aurora. Two different animals. Industrial hygienists are awesome for some things. They're not engineers. Engineers are really awesome at some things, but we're not industrial hygienists. So we have on staff industrial hygienists as well. So when we review a facility, we make sure both people look at it, because you're looking at two different things from two different sets of eyes. Engineers and architects, usually you're driven by your local authorities. Some authorities have no requirements. Recently, I was out in the middle of nowhere, Colorado, where someone had just put together a brand new facility. Now, they hired us to inspect it. That's good. You get out of the car, the first thing he says is, "I'm glad you're here." Like, yeah, it's a long drive. Yeah, we're out here, but no one cares what we do. So they deliberately are seeking places now. They're not in Denver, they're not in Aurora. They know they can get away with stuff if no one's paying attention. So they're looking for the places that still allow marijuana processing, but haven't developed any requirements yet. And they think this is like brilliant on their part. And quite frankly, I think it's because a lot of people don't understand the process. If someone told you it's a closed loop system and it's approved, you go, looks good to me, I'll go here and carry on. You got to dig into, well, how's this really work? What do you mean you let this stuff vent? What do you mean the spent product still has flammable fluids in it? You know, you got to dig in a little bit deeper. How do we get there? Click. All right, where am I going? There are some state-of-the-art facilities. This is a CO2 system, is it? No, it's not. Sorry. Pardon? I believe you're right. Yep. In a facility, though, gas detector down low, gas detector up high. Doesn't hurt to have more than one, but you got to have the one down low. Nice cleanable surfaces. Nothing else in the room. You know, keep yourself distracted. Funny. See a lot of these paint booth styles coming around. I'm not a big fan of them, but you can't argue about the airflow. Gas detector in place, nothing else in the room. Once again, a sweeping system. So they got the flow going in the right way. Not a big fan of the drop ceilings anymore, but they're on the right track at least. Lights, bottles actually stored correctly. More common walk-in hood, waste can that stays in there till everything's vented off. Questions? And I'm not done, but this is a good question part, because the rest of it's all show and tell. Sir?
A lot of the designers using portable Class 1, Div 1 exhaust fans that are used to...
Pits.
Yeah, basically pits, depressions, and concealed and confined space entry. And they're using them in a permanent method to off gas, or to exhaust that gas to the outdoors or not even to the building. Not approved for that use. If anybody sees that, turn them down. You gotta have non-incendive pieces, totally motors removed from the air path. It has to meet the National Electrical Code requirement to convey hydrocarbons. They're trying to get away with using those portable. Well, the guy told me on the internet it was good for that.
Yeah, in fact, there was a slide, really early, there was a slide that showed that.
A green fan is
right.
approved for use in a permanent application.
Correct.
It doesn't meet any requirement of any building code or any of your requirements. I can imagine
Right.
nothing from that, right?
What is it? It's IMC 510. Mechanical code 510 is hazardous exhausts. And there's a lot of requirements that are in there. That gets into, do you need fire suppression in the duct?
Right.
Do you need blowout panels? How thick is the gauge of the metal? When you pass through firewalls, there's all requirements that have to be dealt with. And I can't imagine any flex hose would have, you're not even in the right ballpark.
It's a fire and burns out of the way. It's kind of cool.
Yeah, it's not cool at all. I agree with you.
No, I'm just being sarcastic.
Sir?
So is you all working on an approval? I know NFPA is working on some standards.
NFPA is working on a standard. The marijuana industry is working on a standard. So we're trying to come up with a consensus code. At least we're going to start with best practices. It's going to help. So unfortunately, everyone's busy and it's just moving along very, very slowly. But the goal would be to have the industry themselves come up with a consensus code and then have it adapted by other people. Adopted by other people. So short answer, not that I'm aware of. Yes, ma'am. I am not. Perfect. Because in a vacuum, it will be filled. And that's why I think consensus is the goal. So we need, any consensus code needs to have the users driving it, with the equipment manufacturers, regulators, et cetera, all participating in it. So at the end of the day, it may not be the best plan, but at least it's an agreed upon plan. And I think it'll start out, in my opinion, as a best practices, and then evolve into a you shall. That's my gut feel. Anyone else? Yes, ma'am.
Do you guys provide like routine maintenance or rechecks, periodic maintenance?
Do we provide that?
Yeah.
There is no regulatory driver for that. So we offer the heck out of that. Does anyone take us up on it? No. By law in Colorado, if you make a substantial change to your facility or equipment, you have to have it re-inspected. But no. There's no requirement that you go in every 6 months or every year or every 5 years or every 30 years. Once you're done, you're done. I don't like that. I think it should be on a recurring cycle. I think it's insane that it's not. But there's no regulatory driver right now. Yes, sir.
Have you guys had any accidents with anything you guys have?
Yeah, that one we saw with the lid blowing off. That was one of our systems.
So you were talking earlier, you had a slide where you were talking about the process where they come in with a bag of materials and throw it on your desk and kind of show you how you're giving them advice or, on how to, take it back and
Make it clean.
Are you perhaps kind of taking on some of the design responsibility?
Well, that's,
Where that could be a
we don't think so, but I could see how that could look that way. Because we don't design it. That's the one thing we will not do. We will not tell them, you have to do it this way. We'll point out what's wrong. You have no relief. You have the wrong materials. We'll point it out that way and provide a punch list for the equipment manufacturers. And if you've ever seen our facility reports, it's similar. We go into a facility, we don't tell them how to fix it. We just go through, I think there's, 20 different sections, and tell them you're deficient or you have passed. And then we back off. We want to maintain our third party, what's the word? Not involvedness. Objectivity. Yeah, that's it.
Does the review also include the ventilation for, telling them on the design at what specific points to be pulling?
For a facility?
From point of extraction or point of generation, or does your review include the ventilation review as well?
Yes, for a facility. For the equipment, no, because who knows where it's ever going to be. When we walk into a facility, ventilation is on our list. And we don't do the ventilation inspection. We want to see their balancing reports from their certified balancing people. We're not certified. So we rely on that piece of paper that says it got the flow it needed. We look at the building plan or the system plans that say here's what they were shooting for. The two match, we're golden. But we don't do the capture velocity calc, for example. We want to see the velocity capture calc. And then that gets embedded in the report. So we rely on the experts in their fields to do their job right, and we put it all into one big report. That's more like how we do it. Sir?
So it seems like there's an astronomical number of people doing this now, and there's not that many people doing what you're doing. So are all these facilities really following the law?
Yes, they are. The Colorado Med requirement is that you shall have your facility reviewed by an industrial hygienist or a professional engineer, and that report shall be on file when you're inspected. It does not say they submit that report. So it's not a proactive thing, it's a back pocket thing. So until you walk into the facility as an inspector and say, show me your report, you don't know. There's no they submit it, it gets approved process in most jurisdictions. Now, Denver does it different, Aurora does it, Commerce City, a lot of jurisdictions are getting up to speed and saying, hey, show us your report, darn it.
Should that be a part of getting your permit?
Yes, I think it should be, but it's not in the Colorado statute. So they're relying on individual jurisdictions to make it part of their process,
It's
which,
not in the building code. We put it in regulations, so a license isn't given to anybody, no product can be moved into the room until a license has been handed over to the applicant. And that's after the fact, after C of O has been issued, after we've gone through and done a regulation inspection, which includes PSI's report or any hygienist report that accepts the process as it is.
I did not know that.
They don't do anything until we see those.
Okay,
Are you a part of the building department? Yeah, I'm the chief electrical inspector for the city of Aurora.
perfect.
So.
Well, then I stand corrected, so yes.
We do. As part of it, we didn't accept one of the extraction machines, CO2 or hydrocarbon without this. We set our regulation in place first.
You're talking about the machines, not the facilities.
And facilities,
Okay,
too.
just a second. Two different, yeah.
Everything. The hygienist, generally, the hygienist will come in and they have a suggestion, and then we look at that suggestion of how they're going to operate. And as we go through the construction process, we verify components, the fans, the size, the CFM, everything that goes on with it, whether or not we have the required wiring that's going to be in that location, or if there is any wiring in that location. And then at the end of it, we'll go through and we'll make sure that that was met, and that the hygienist has come back out and verified that what he suggested, or the PE, what they wrote down as a requirement was adhered to, their letter of acceptance, and then we accept that letter of acceptance and move on.
Perfect, that's how it should be.
So it sounds like Denver's not doing that.
Denver is now doing that.
They are.
Yeah, we were very, very busy this year. Yes, sir.
On the, so, you know, you have an electrical component, you have a mechanical component, fire component. So we're talking about the industrial hygienist, which is, ID, but what about, what's the kind of engineer is doing?
It does matter. First off, you're not allowed to practice outside your knowledge. So that's the rule.
So are they getting 3 or 4 engineers?
Our reports are. So our reports have a mechanical and a fire protection engineer on every report. We also bring in electrical engineering as needed. Some of these places don't need it. So ours do. Plus we have an industrial hygienist, like I said, who helps us out.
So far, are your competitors doing that? 'Cause it seems
No.
like, I mean, you've got a big staff, so you can do it, but what about other ones?
They're inadequate. I'd also say, for the record, that an industrial hygienist is not permitted in Colorado to perform engineering analysis. That is licensed engineers and architects only, and DORA has backed us up on that. So unfortunately, our rules say you can have an IH or a PE, but the Colorado law says you cannot perform engineering services without an engineering license.
So let me ask you a question at the city level then. What are you guys accepting?
The IHC, his is a recommendation, and it's strictly life safety. That's all. It's a bunch of, it's everything about personnel protection. All right. So when they set up a capture hood or a big mandate a specific airflow, as long as the code backs up that requirement, we're good. We can move forward with that. If they do anything less than that, then we reject their application. It doesn't meet the requirement of the code. Code alone as the code stands alone, it can protect the entire operation, to be quite honest with you. They build it to the requirements of NFPA documents 70, 58, IFC, all those codes address every aspect of extraction, as long as, and you just have to look for it. My plans examiners over here have spent hours digesting everything that there is about explosive gases, liquefied gases, you know, the conversion from gas to liquid, that type of thing. We went through the whole thing and understand the basic operation of the machines too, so that we could develop something that was responsible. You know, this is something that's applicable. And we know that the industrial hygienist is not that engineer person. We know that his primary purpose, or their primary purpose, is people. Protect those people operating the equipment. And that's important. And if capture systems, like those capture hoods, they just take us, no problem. Go ahead, run all day inside that. They put the equipment in there. Like he said, it's a passive, there's no arcing or sparking incentive devices inside those capture hoods. The only exposure is when they vent, when they open up the cylinders, the capture vessels and the cannabis cylinders. That's the only real hazardous time. And because there's so much ventilation in that room, it's accounted for and it's dissipated quickly. You know, so the industrial hygienist does not do what a PSI does at all. I rely on PSI heavily. Every time I look for their equipment, their stamp, whatever, it's like, okay, I know it's good. It's met that requirement and it does its job.
Thank you.
I'd like to say, there was one thing about licensure, I forgot what it was, I'll come back to it as soon as I remember, sorry.
Okay. Any other general comments? The rest of it's all show and tell of bad things. Okay, because it's 1 o'clock if you had to leave. All right, where were we? Blah, 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 blah. Wrong direction. 50-50 chance. This was as we show up, taking a look at someone's facility. Extraction tech, great machine. This is an old version of an extraction tech. Has the old non-classified thermometer right next to a 220 outlet. Right in a, what do we want to call this? A less than clean environment. That's a refrigerator or is that an oven? I can't remember. Thank you. So you know this facility?
No,
I've
worked in kitchens.
Okay, yeah. So this is what they were saying. Is this okay? We said, no, it's not okay. This is another favorite. Outdoor storage. Yay. Cage. Yay. That's the only way in and out of the building, right next to their gas storage, which is also their smoking break area. And remember, this is unscented. If this was rhino tanks, at least then you could say, well, maybe they'd smell it. They would never smell this. This is crazy. But that's what they do sometimes. Boom, boom, boom. Flammable liquid storage. This is your typical Lowe's refrigerator. This is not acceptable. You can use refrigerators and freezers, actually, but they're rated for what you want to use them for. You got to convince them, no, this is not just go pick one up at Lowe's. You're going to go get a Fisher Scientific or somebody who actually knows what they're doing, please. This is a hazardous exhaust system. Okay? Well, this is actually the part that's kind of close. The fan is actually sealed, it's venting, but that's the exit. So that hazardous exhaust comes out of the building right over their swamp cooler, sucking the air back in. It is filtering it. It was a beautiful setup. But so you got to go look sometimes beyond just what looked in the room. Boom, boom, boom. This is another one that's, I'll call, less than cleanly. Okay, but all right, it's got a lot of space. And this is really early photograph. This was open blasting with hoods, so at least he knew it's a hazardous situation. I better be doing this in a hood. And once again, follow the exhaust ducts. So to his credit, he put no smoking signs, and he did have yellow cones out there to make sure no one went into the smoking zone while running. But we didn't approve that. This is another one. Looks kind of good. It's a little narrow. I'd get a little scared of being in tight places. Exhaust on the ceiling. Mistake number one. LPG gases are heavier than air. Putting an exhaust in the ceiling isn't really going to cut it. So, all right, you already failed. But let's trace this one. His exhaust went out into the rest of the building. So you got to really follow through. So even when guys think they're doing it right, they don't always do it right. This is a classic. He wasn't using a heat gun, but this is something you get from, Kohl's, or Sears or Target heat plate to let it go. Absolutely not rated for this environment whatsoever. Yeah. Now, I'm not an electrical engineer, but I thought that there was something wrong with that, and I got verified that, yeah, you're not allowed to do that in a commercial facility. And you're not really supposed to be doing this either, hooking up our gas detectors. Another gas detector. Okay, so this is a butane system over there next to the blue table. That is a fired boiler right there. So that's the classic ignition source within, what is that, 5 feet? With no ventilation, of course, also. Well, that's fire load, you know. If you want to make it, if you're going to go big or go home in this one, you know. When this one goes off, it's going to be awesome. This is kind of common. Just reminding them that you got to have, these are tanks just out on the floor. You really shouldn't be doing that. They should be secured properly. We require that they have training in handling gas cylinders, and we require them to show us proof that they have training in gas cylinders. Yes, sir.
That's one of our regulations, is that all the operators are certified by the manufacturer on how to operate the machinery, and that all operators of any hydrocarbon have a gas transfill certificate as well, gas purveyor. So
We agree.
those two things are paramount in the safe operation of these things. If you don't have it, we don't let them operate without it.
And I applaud that, because it isn't that common. It's not something that's intuitive, and having someone tell you how to do it right the first time, I think is an awesome idea.
I had Dabber Dan, who's on the cover of it, High Times Magazine, tell me that he's been blasting for 20 years. Like that, where at? He was California. He says, "I'm not going to do it. You're going to get a license. You're going to get a certificate."
Yeah.
And then also, we actually asked that the manufacturer go into contract with the operators so that maintenance can be provided on a quarterly or biannual basis, so that they come out and they're looking at the wear and tear on their nuts and bolts and their gaskets, because the gaskets can deform. They're definitely.
I think that'll help start separating some of the wheat from the chaff.
Absolutely.
Because there's a lot of manufacturers out there, not all of them have been reviewed, period, and a lot of them don't have the capabilities to maintain something like that. So that's
Every machine that we have in the city has been reviewed by your company. So.
okay. That's good. Yes, ma'am.
It's a gas transfer. Teaches them how to use.
It's the basics. It's the
Exactly. It teaches you to use a nitrogen to push butane. Butane's such a mushy gas. It's like, you ever dug in the sugar bowl and never hit the bottom? That's basically how you push gas. That butane, it moves out of the way if you were like digging in on the beach and the sand falls back in. That's what butane is. So you push it with a nitrogen or another gas, something along that line. That will help get that gas transfer is awesome. Everybody gets that. They're like, they do their job much better.
And there are a few vendors now. At one point, there weren't that many, but there's a vacuum. People filled it.
Butane is coming from Texas. It's being shipped here from Texas because there's not enough of it in the state. So these guys are getting massive quantities on site, storing it while they can buy it. So we got 300 pounds outside and 150 inside. It's like,
Other ones. This is a really good gas detector. That is the ceiling. So for that to go off, the room would already be filled up to way above your head. It's also really not installed per the manufacturer's instructions. That's a Class 1 Div 1 head with a bare wire being through an open conduit. But they did it. Oh, where was I? This is a, that's a commercial not a commercial freezer. That's a freezer like you'd get at Home Depot. They're using that to store their ice and their LPG inside the building. We don't like that. This one's a more, oh, this isn't it. Is this it? Well, it's a kitchen hood for one. Kitchen hoods don't work. But hey, I got a hood. Why are you failing me? Because it doesn't work for the system you're trying to use it for. But I think there's more to this slide. Let's take a look at that. Yeah, there is. So it's the same floor, right? So we're looking around, and this is a CO2 system, by the way, if I remember right. CO2. So, not a big deal. But wait, what is that light behind the machine? Like, what the heck? No. That used to be a bathroom. They yanked the toilet out, they removed the pipe, and left the hole. So now you have a CO2 facility, hazardous, heavier than air gas that you can't smell. This room had a gas detector. Well, that's not it, but they had one. But directly below them in the basement was their packaging plant, where all their workers are downstairs with an open hole in the floor, packaging. No gas detectors, and no clue as to why we were freaking out that that's a bad idea. So sometimes you got to look a little bit more. And we wouldn't have even noticed it if the lights would have been off. But the fact that the only way we caught it was the lights were on, you could see through the floor. There's a reg that some jurisdictions require that your lights can't be on unless your fan is on. I don't mind that at all. These guys took that to heart and had their gas detector also wired. So the gas detector's not on unless the lights are on. So when you come in the morning, you flip on the lights and the fan and the gas detector. It could be a spectacular day. Speaking of gas detectors, we require you have a fixed gas detector that doesn't get messed with, plus you have a portable one. Why? 2 reasons. Portable you want. That's the only way you're going to find a leak. If your big one's going off, all right, well now you know there's a leak, go try to find it. Don't use a match. You use a portable gas detector. You also make sure you have a portable gas detector so nothing comes out of that room until it sniffs clean. Okay? 2 good reasons to have one. They had one. There's no batteries, but they had one. So we make sure that they actually are working systems that do what they're supposed to. Oh, you've seen the electrical rat nest before?
FRP on the walls?
Yes, I think so. I can't tell. But FRP I've seen all over the place.
But it doesn't,
Well, these wouldn't meet that, right, unless they're listed.
probably, yeah, unless it's a listed piece or something. It will melt down. It could happen. If you have capacity, though, I wouldn't worry about the
What was this one?
No, on the floor.
Ah, that's it. Yes. I knew there was a reason I had this slide. Thank you. Blower, not rated for the room. In the room, rather than sucking out. Plus, I don't think you want to pressurize that exhaust like that would do. You want it to have a vacuum in the exhaust, so if there's a leak, things leak into the exhaust, not blow out of it as it goes through the building. This is another favorite one. We tell our clients, everything in that room's got to be Class 1, Div 1, or Div 2. They go, okay. So they went and bought their Robinair vacuum pump off the internet for $50, cut the cord off, put on a Class 1 Div 1 plug, and tell me, did exactly what you told me to do. Why are you giving me hassles? So sometimes they just don't understand what you're trying to help them do. You got to be a little bit more explicit and say, no, you really need a Class 1 Div 1 pump, not just the plug part of it. And I'm embarrassed that that's happened more than once. The people have done this. This is not one-timer. What was that one? Gas detector. Care Savers. Care Savers, we approved 2014, 2015. We're no longer approving them. They're not. Care Saver themselves say, yes, they can handle LPG gas through the system. But the rest of it is not rated for a Class 1 Div 1 environment. So if you're going to make a requirement that says this is a Class 1 Div 1 room, because we're venting all the time on purpose, then these really aren't going to work anymore, unfortunately. So that's still there, but get rid of them as you see them. And that's the highlights of the bad stuff. Any further questions? Okay, well then remember, if you need the credit, sign up for it. I'll make sure you get it. If you don't need to pay attention. If you're leaving, these are feedback forms. Tell me how I did. Be rough. I got a thick skin. And then if you have any other questions, or we want to have presentations in the future, who's the guy who organizes this? Let us know. We can come up with something specific for what you want to hear. Okay? This is kind of generic, but it's a good start. So feedback forms if you want them, and thank you for your time.